Hi there! Let's talk about electricity. What is electricity? Electricity is the most commonly used form of energy. It is used to run everything, like computers, phones, microwave ovens, and now even electric cars. But how do we get all this electricity? We get it from power plants that burn coal and oil, collectively known as fossil fuels, to produce this electricity. But the burning of fossil fuels produces a lot of harmful emissions, and it is killing our planet. So what do? How do we get energy that is clean as well as sustainable? Well, it turns out we have the answer right in our sky. The sun. It is an immense source of energy, and that energy reaches us in the form of sunlight. The amount of energy that falls on the Earth's surface in the form of sunlight in one day can be used to run the entire world for one whole year. Now, isn't that just great? But wait, how do we turn all that sunlight into electricity? We use solar cells. You might have seen panels like these on the rooftops of buildings. These are solar panels, and a solar panel is basically a group of many solar cells arranged together. With solar panels, we can just sit back and relax as the solar cells soak up the sun's energy to run our homes. How do solar cells work? To understand that, we should know about a class of materials called semiconductors. They are called so because the ease with which they let electricity pass through them lies between insulators, such as wood, that do not let electricity pass through them, and conductors, such as metals, that let electricity pass through them very easily. When semiconductors are arranged in a special configuration known as p-n junction and exposed to sunlight, they convert that sunlight into electricity. The mechanism behind how this really works was first completely understood by none other than Albert Einstein. He even won a Nobel Prize for it. Here is a basic explanation of what that theory involves. What happens is, sunlight is made up of particles known as photons, and when these photons hit the p-n junction, they knock loose electrons from the atoms of the semiconductors, and these electrons are free to flow, and electricity is nothing but flowing electrons. Let us understand the mechanism with the help of an analogy. This is a commonly found game at carnivals called the high striker. The objective of the game is to strike the hammer so hard so that the metal piece flies up and rings the bell. Here is how it exactly works. Now, think of the hammer as a photon, the metal piece as an electron, and the ringing of the bell as the flow of electric current. So if a photon has enough energy when it strikes the atom, it will knock out an electron and make it flow in the form of electric current. This energy requirement to make the electron flow is called the band gap. Now we know how solar cells work and that they're made up of semiconductors. So let's take a look at exactly which semiconductor is used to make solar cells. Well, most of the solar cells today are made up of silicon, the chemical symbol for which is Si. And silicon solar cells have an efficiency of 25%. That is, they convert 1/4 of the sunlight that falls on them into electricity. That's a very good number to have. But there are certain disadvantages to silicon solar cells. First, they are very expensive to manufacture, as the process involved in making silicon solar cells is very complex. Second, they are rigid and heavy, which drives up the cost of installation. So overall, silicon solar cells are quite expensive. This is where nanotechnology comes in. What is nanotechnology? It is the science of things that are extremely small, about 100 nanometers. To put that in perspective, think of the head of a pin. That is 1 millimeter in size, and 1 nanometer is 1 million times smaller than that. Nanotechnology can help us in two ways, solar cells, either increase efficiency or lower cost. So let's take a look at efficiency first. The first way that nanotechnology can help us in increasing the efficiency of solar cells is by using quantum dots. Quantum dots are semiconductor crystals that are very, very tiny, about 10 nanometers in size. When things are so small, we enter the realm of quantum physics, and the strangest of things begin to happen. The green spheres in the schematic here are the quantum dots. So let's see what happens inside them. This squiggly arrow is a photon, and it is striking an atom. In a normal solar cell made up of silicon, we get 1 electron for 1 photon. But with quantum dots, we can get more than 1 electron for every photon that strikes. It's like getting 2 rings of the bell on a high striker with 1 stroke of the hammer. Isn't that amazing? So we get more electricity for the same amount of sunlight, and hence our efficiency goes up. nanotechnology has another ace up its sleeve for increasing efficiency. Light is a wave, and each wave has a wavelength. Sunlight is a mixture of different colors with different wavelengths, and those wavelengths lie between 400 to 700 nanometers. So, if a solar cell has features that are smaller than the wavelength of the light that is falling on it, it traps the light and does not let it be lost due to reflection. This is known as light trapping. This can be accomplished with wires that are nano-sized. As seen here in this image, each wire is about 180 nanometers in size, which is smaller than any wavelength that is in the sunlight. Or it can also be accomplished by covering the surface of the solar cell with a mesh that has holes that are, again, nano-sized. The holes in this image are 175 nanometers in size, again, smaller than the wavelength of light falling on the cell. For the cell having the nanomesh, the difference can be seen in these two images. On the top, there is a cell without the nanomesh, and it appears red. On the bottom is a cell that is with the nanomesh, and it appears black because it is not reflecting any light whatsoever. This means more light is absorbed into the cell to be converted into electricity, and we get higher efficiency again. Let's talk about cost next. Nanotechnology enables solar cells that are cheap to make and easy to install because they are thin and flexible and use very little material. So let's take a look at how these cells are made. Semiconductor nanoparticles can be used to form inks, which can be sprayed onto large sheets of plastic to print solar cells, just like printing newspapers. And this makes manufacturing solar cells cheap in large quantities, and these light and flexible solar cells can be easily installed without spending much money. More time and effort is required for nanotechnology cells to become completely competitive with silicon solar cells, as it is hard to exactly control what happens at such small sizes. But it can be hoped that in the not-so-distant future, nanotechnology solar cells will outdo the conventional solar cells and pave the way for a clean and sustainable Earth. Thank you for watching this video. I hope you had fun.